coordinating units of tens and ones. This instructional sequence is designed to foster children's development of initial conceptual foundations for the base 10 place value system. It provides the basis for reasoning that involves coordinating units of 10 with units of 1. It is important for teachers to understand that developing the conceptual foundation for coordinating units of tens and ones is a separate matter from, though it's related to, using the conventional notation of the standard U.S. algorithms for addition and subtraction. As an aside, we note that in some other countries, other algorithms are used as well. Traditional U.S. instruction has not always made this distinction between the conceptual foundations and the algorithms, with the result that teachers sometimes view children's learning to coordinating units as synonymous with developing proficiency with the standard U.S. algorithms. In these videos, we clarify this distinction. We devote a first set of videos entirely to instructional activities designed to foster the basic understandings of coordinating units of tens and ones. In a second set of videos, we will address the instruction for adding and subtracting two-digit numbers based on coordinating units of tens and ones. This sequence begins with students engaging in activities that involve a single quantity. Students are presented with a quantity either all in ones or in tens and ones, and they transform that quantity either by packing or unpacking. These activities shift from students packing and unpacking using the physical materials of Unifix cubes to reasoning from visual imagery. As the sequence progresses, the activities involve changing the quantity by either increasing or decreasing the initial amount. Here again, students begin by using Unifix cubes to enact the changes and then progress to reasoning from visual imagery. Teachers that have used the structured numbers instructional sequence will notice similarities in how the two sequences progress. In both sequences, students work with a single quantity in part 1 of the sequence, and then in part 2, shift to working with tasks that involve changing the initial amount by adding more or taking some away. Likewise, within each of parts 1 and 2, students shift from using physical materials, the arithmetic rack in the case of structuring numbers, and Unifix cubes in the case of coordinating units, to reasoning from visual imagery. This is the first of 3 videos devoted to part 1 of the coordinating units instructional sequence. Activities in part 1 of the sequence involve reconceptualizing a quantity by shifting between units of 10 and units of 1 as appropriate. There are 5 activities in part 1. They are introducing the candy shop scenario, packing candies, circling candies, candy flash, and the transformation activity. Some of these will be used only once or twice, while others will be used often. We will describe the activities in detail and explain different things children do. In doing so, we clarify the conceptual demands of the activities and how they function to help children advance in their understanding of coordinating units. This coordinating units instructional sequence is based on what is called realistic mathematics education instructional design theory. Accordingly, it starts with a scenario that children can use as the basis for personally meaningful activity. Now here I'm going to describe one way to introduce the scenario. A woman named Mrs. Wright makes and sells candies in her home. When she first opens her business, customers stop by and buy a small number of candies. Maybe they buy 5 chocolate candies or 3 orange candies or 4 peppermint candies. People like her candies so much that soon they come to buy a lot of candy. They might buy 65 chocolate candies, or 32 orange candies, or 28 lemon candies. Business is so good that Mrs. Wright opens up a candy shop. But she has a problem. The customers have to stand in line a long time while she counts out the candies they want to buy. It takes her a long time to count out 65 candies, or 32 candies, or 28 candies. Her customers have to stand in line so long. Mrs. Wright realizes that she has a problem. What can she do to solve her problem? At this point, the teacher invites students to make suggestions for how Mrs. Wright might solve her problem. Typically, suggestions include that she hire help or that she count out and prepackage candies in advance. The scenario continues by explaining that Mrs. Wright decides to count out and package candies in advance, and she decides to pack up candies into rolls. Now she has to decide how many candies to pack into each roll. Her reason for packing candies into rolls is to make it efficient or faster or easier for her to get out the number of candies the customer asks for, so that she doesn't have to count the candies one by one. Now, at this point, the teacher invites students to make suggestions for how many candies Mrs. Wright might package in each roll. Typically, suggestions include 5, 2, 20, 100, 10, and other numbers. The scenario continues by explaining that Mrs. Wright decides to package 10 candies in each roll. She chooses 10 in each roll because she knows how to count by tens. There are many ways to introduce the scenario. I've given one example. Each teacher will use his or her own ideas to make the story real to the students. It is important to take sufficient time to make the scenario as realistic as possible. The purpose of a scenario is to create a realistic situation within which students can reason. Students can imagine working for Mrs. Wright. They can easily imagine how they would go about packing up the candies into rolls in her shop when more are made, or unpacking as needed to sell to a customer. In this way, the story creates the background for the physical activity the children engage in, which eventually evolves into reasoning about quantities. And as a result, we will not need to give procedures for the children to follow. I want to emphasize that by the end of the introduction, all students should understand that there are 10 candies in each roll. In introducing the scenario, it is important to solicit several answers from students about how many they think might be in a roll and their reasons for choosing their amounts. The purpose for inviting children's input is not to see if they can guess 10 candies in each roll, but is to get them to feel invested in the storyline. As we said before, the reason Mrs. Wright puts 10 candies in a roll is because she knows how to count by tens, so that makes it easier for her to count out large quantities. The scenario is introduced one time, but many teachers review it briefly for a few days to ensure that it is familiar to everyone in the class. The physical materials students use with this instructional sequence are Unifix Cubes. The teacher explains that these cubes are pretend candies in Mrs. Wright's shop. The feature that makes Unifix Cubes ideal is that individual cubes can easily be snapped together to create rolls. So students can be workers in Mrs. Wright's candy shop. They can snap 10 pieces together to create a roll. In other words, they can physically change 10 units of 1 into 1 unit of 10. Likewise, they can unpack a roll if needed by breaking it into individual pieces. In other words, they can physically change 1 unit of 10 into 10 units of 1. It is for this reason that we recommend against using materials that are typically called base 10 blocks. With those materials, 10 individual cubes can be lined up, but the result is a line of 10 individual things. It is not one thing, one entity. You cannot pick it up and hold it like you can a stick of 10, a roll made using 10 Unifix cubes. Classes we have worked in typically have a supply of 50 Unifix cubes per student kept in Ziploc bags of 50. That way each child can have a bag of 50 cubes to use to solve tasks. It is helpful if all of the cubes in a bag are the same color so that when they are packed up there is a unity to the physical appearance of a roll once packed. When tasks involve quantities beyond 50, 2 students can work together and share their cubes to carry out the task. We recommend that the cubes be in sticks of 10 within the bags. That way, children can easily access rolls without having to pack them up each time. Finally, a pragmatic matter for the teacher's benefit is this. Every time students put their materials away, they should make sure that the cubes are packed into tens so that the teacher doesn't have to pay attention to that detail continually. As we discuss the instructional activities, you will see that the first activity, packing candies, is an exception to what I have just said. The first activity, after introducing the scenario, is one we call packing candies. It is designed to focus children's attention on the difference between thinking in terms of ones, individual candies, and thinking in terms of tens, rolls. Children work with a partner. Each pair of students is given a bag of loose Unifix cubes, and they are told that these are pretend candies. They're told that they are workers for Mrs. Wright and are to pack up these candies into rolls, but before they begin, they should first estimate or guess how many rolls there will be. As they begin packing, they might decide to revise their estimates. An important aspect of this activity is that students are not told how many loose candies are in the bag they are given. They are expected to make an estimate of the number of rolls based on just looking at the bag. I want to clarify here that the intention is that the various bags of loose candies given to students are not all the same. Some might have 58 candies, some 31, some 97. In other words, some will appear to have only a few candies, while others will appear to have many candies, and students are aware of whether they have only a few or they have many. After students have finished packing their candies into rolls, there's a class discussion in which each group shares their initial estimate of how many rolls they would get and how many rolls they really did get after they packed them up. For this discussion to be meaningful, it is important that as they share with the class, the children display their packed up rolls for others to see. I want to explain what I mean by this and why it is important. For example, suppose Joe and Sam had a bag with 46 loose candies. Of course, these boys didn't know how many there were to begin with. After packing them up, their desk looks like this. When it is their turn to share, they show the class what they have and tell what their estimates were. Next, they have to tell a class how many rolls they have after packing. What would we expect them to say? You and I can see that they have 4 rolls, but in our experience, it is not necessarily obvious to Joe and Sam. In fact, it is quite common in this situation for the boys to report that they have 40 rolls and for many in the class to agree. What is going on here? Why did they say 40 and not 4? These boys are not making a distinction between the number of rolls and the quantity of candies in those rolls. They are not distinguishing between the number of tens and the quantity in those tens. An intervention at this point, either by the teacher or another student, might be to point to one roll and say, "How many rolls is this?" Now, Joe and Sam might reply 10. These boys are answering the question, how many is this, in terms of how many candies, that is, how many ones. They are not yet differentiating between how many ones, pieces of candy, and how many tens, rolls. And that is precisely the purpose of this task, to call attention to this difference. Notice how the scenario permits us to talk about pieces of candy and rolls rather than ones and tens. And that is an advantage because the words pieces of candy and rolls permit us to avoid using numerical quantities in the conversation. It is less confusing to talk about how many rolls than to talk about how many tens. Even so, the issue goes beyond the use of vocabulary, of which words we are using. It is a conceptual issue and precisely the issue this activity is intended to bring to the forefront. We know from extensive experience in many first grade classrooms that the discussion about how many rolls is often a protracted one. Even after agreeing that Sam and Joe have 4 rolls and not 40 rolls, this same error is likely to come up again and again as other groups display their packed up candies and talk about how many rolls they have. Teachers new to this activity are often amazed at how pervasive this misunderstanding is. We want to emphasize that this is a conceptual issue and one that takes time for children to develop. It is not just a slip of the tongue. In fact, being able to coordinate tens and ones is precisely the goal of this sequence. So it is important for teachers to move on to the next activities that continue to work on developing these basic understandings. The intention is that this activity is to be used only one time. The class will have many discussions that involve distinguishing between the number of rolls and the total quantity in those rolls in the activities that follow. I want to emphasize that the purpose of the Packing Candies activity is to provide a situation where students are presented with a quantity in units of 1 and they are asked to reorganize it into units of 10. The students physically change the materials from units of 1 to units of 10. In other words, they actually create units of 10 from units of 1. They physically make a roll, a 10, from 10 loose candies, ones. As the sequence progresses, students will get to the point of conceptually making a 10 from 10 ones. At this stage, however, it is done physically with materials. I want to add 3 notes to teachers about this activity. 1, it is essential that this task is about the number of rolls and not the number of candies. In our experience, teachers sometimes misunderstand this task and mistakenly ask children to estimate the number of candies. But of course, that completely misses the purpose of this task. So teachers need to be careful to avoid this error. Second, it is important that all of the Unifix cubes in the loose bag are of the same color. The reason is simple. When all of the Unifix cubes a pair of students have are the same color, the rolls they will get have the appearance of a unity. If a roll would consist of a variety of different colors, the sense of one thing is lost. And third, as we've said before, it is important that the cubes that are used actually snap together. Unifix cubes are ideal for this purpose. Sets of materials, typically called base 10 blocks, are inappropriate because while 10 ones can be lined up together, they do not actually snap together to create a single entity, a 10. The next instructional activity, circling candies, is similar in some ways to the prior packing candies activity. Here students see a picture of a number of individual candies shown in an array. And their task is to first estimate the number of rolls there would be when the candies are packed up. And then, after recording their estimate, to circle groups of candies to show packing them into rolls. Here you see an example of a page students are given to work on. As you can see, there are 2 separate tasks on this page. The circling candies and packing candies activities begin the same way. Students are presented with materials in units of 1. Individual candies. Then they begin by estimating how many rolls would be if the candies were packed up. The difference between the 2 activities lies in what happens next. In the packing candies activities, students use Unifix cubes as pretend candies to physically create rolls. They physically change 10 ones into 1 10. Here students circle candies to show which ones they would pack into a roll. I want to emphasize again that as with the packing candies activity, it is important that the teacher not misinterpret this activity and ask students to estimate how many candies there are. The entire purpose of this activity is to get students to reconfigure a set of 1s into sets of 10s. That is, to reconfigure a collection of individual pieces of candy into rolls of candy, and to think about the number of rolls there are. As a pragmatic point, we note that it is advisable to have children work alone rather than with a partner on the circling candies tasks. The reason is simple. It is virtually impossible to share a page like this one. Each child will want to do the circling, so why not give them the chance to do so? Here you see 2 different ways children completed the tasks on this page. Teachers often choose someone's work to display to the class to initiate the subsequent class discussion. The focus of the discussion is not on how the circling was done, but rather on how many rolls there are after packing. And once again, the issue that arises in the discussion is to clearly distinguish the number of rolls from the quantity in the rolls. In the second task on this page, there are 10 rolls after packing. But it is not uncommon for more than a few children to say that there are 100 rolls. One approach teachers can use is to say, let's count how many rolls there are, and then count together as a class. 1 roll, 2 rolls, 3 rolls, 4 rolls, 5 rolls, 6 rolls, 7 rolls, 8 rolls, 9 rolls, 10 rolls, as the teacher points to the individual rolls. And then there are 8 pieces left over. And then say, now let's count how many candies there are, and count together as a class. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, as the teacher points to the individual rolls. And then continuing on, 101, 102, all the way up to 108, as she points to the remaining 8 loose pieces. I want to emphasize something here that many first grade teachers already know, and that is that children can often say the number word sequence, 10, 20, 30, 40, etc., without knowing that the difference between 10 and 20 is 10, or that the difference between 20 and 30 is 10. Saying the number word sequence might be a rote activity for them. It might be like reciting a poem, but it might not have any quantitative meaning. We know this because if we ask a first grader how far is it from, say, 10 to 20 or 20 to 30, the child might have to actually count 21, 22, 23, all the way up to 30 while keeping track on his fingers to know that it's 10. These early activities in this coordinating units sequence that involve reorganizing items presented in ones into units of 10 are important to help students develop these understandings. Therefore, we have to be careful to not rush through these activities too quickly. They seem so obvious to us as adults. Even so, we encourage teachers to continue to push forward to other activities in the sequence. We recommend spending 1 or 2 lessons, but not more, on the Circling Candies activity. This concludes video segment 1. The next video segment is devoted to a discussion of the third instructional activity, Candy Flash. A note to the teacher, a picture that can be used to introduce the candy shop scenario, and several pages of Circling Candies tasks that can be used with students are available on the website.